far as some of the questions people were asking about, was forgetting about how the trig functions work. And I think there was one of them where it said find the 6 values of theta, where I think it was, oh geez, which one was it? Or 18, 4 and 13, okay. So you had a 13 and a 4, and it asks you to write out the 6 trig functions at theta. That doesn't mean you're solving for theta, you're just writing out the side ratios. Let's not do it now. Let's see this. Are you okay? You want to do it? Tomorrow. At least get you back. Like, no, I'm not going to. You can call forever. I'm a jerk. I'm not big of a jerk. All right. Should have laughed nicer. Anyway, in order to do this, first thing you have to do is find that missing side length. This is pretty quick and easy to do that. It's just straight Pythagorean theorem. So you got the 169 from the 13 squared, back out the 16 from the 4 squared, you get 153, and it gives you the square root of 153. When you start to go through your trig functions, at this point, the easiest thing to do is just to write it out. Okay? Start with sine. You know the sine of theta is your opposite hypotenuse, so sine is your opposite over hypotenuse. The cosecant, which is the reciprocal trig function, is just the reciprocal of a fraction. You just flip it. Okay? The weirdness comes into play when you start to worry about the root. So you've got your cosine of theta is your adjacent, the 153 over 13. But then your secant, you have to reciprocal it. You always rationalize denominators. Yes, ma'am. Oh, wasn't it simplifiable?
Yeah, it was.
Oh, it was? For some reason I thought it wasn't. All right, so would you say it was 3 root 17? Yeah. Okay, so when I flip this, then I know I have to multiply the top and bottom by the square root of 17. Okay? So your numerator gives you 13 root 17. And then 3 times 17 is that 51? I think that's 51. Yeah. And then you'd be done. Okay? You always rationalize your denominators. Never leave a radical in the denominator. All right? That's kind of our main rule for all this stuff. And then obviously when you go to tangents, then same thing will happen. You'll rationalize it out, and then flip your reciprocal for the cotangent one. Okay? Those probably weren't terrible, were they? I'm remembering how to do those. Okay. What else did you have on 13.1? Any elevations or solving triangle ones? Are we okay on those? Solving triangles are easy. Those should be pretty quick. Don't worry about 44. I'm not going to ever ask you about vertical speed and stuff like that. I apologize, I forgot the script. It's a little weird to make it go. I'm not really worried about it, so don't worry about it.
I just assumed since it was 800, I just like doubled it.
Oh, you take, I think it's half or something. I don't remember how it works it out. Yes, sir. 51, sure. Yeah, it's okay. I'm not gonna ask you guys about vertical speeds and stuff like that. Excuse me. All right, 51. That's this whole big giant surveying of the island. Okay. So here's what happens. You are surveying an island because why wouldn't you? Because it's what you do. You're up in a helicopter trying to determine the width of an island, illustrated at the right. You are 3,000 feet up in the air, and you have an angle of depression to the front of the island at 39 degrees? So if your angle of depression is 39 degrees, what's the angle of elevation? 39. So you use that 39 here to figure out this distance. So that gives you tangent. So you have a tangent of 39 is your vertical over your horizontal.
It doesn't matter if I use the front angle.
Oh, to get to here?
Yeah.
And you use what, 41? Oh, 51. 51, yeah. That's fine. Then you'd have x over 3,000.
Yeah.
Yeah, you're okay. So then you get x is 3,000 over the tangent of 39. So pressing buttons, 3,000, tangent 39, yes. I have 3,704.69, 3,000, I forgot already, 704.69. Okay. That gives me that front. Now the other one, what is it, 27 degree? The 27 degree down is also here. That gives you this overall distance. Find that, subtract the first one. Okay. You're still going to use tangent again, but now you'll use it with a 27 degree down. So you'll have 3,000 divided by the tangent of 27. And that gives me 588783. 588783. And I subtract those two. $2183.14. That gives me the overall width. Does that make sense? Yeah. Remember, all you're doing is if you start looking at it, just redraw it and retrace it out. Okay? No problem.
But you just added.
I subtracted them. So I found the total and I subtracted out the front. Okay? What else you want to look at in those? So again, guys, we got a lot to do today. So let's see here. This one will tell you have an incline. The track of the incline is 800 feet long. The angle of elevation is 30. How high up does it go? Well, the track is the incline. How high up does it go with an elevation of 30? That's your height. If your incline is here at 800, isn't that across from the 90 and the 30, 60, 90? Yes. What's half of 800? There you go. 30, 60, 90. So across from 30 is half of what it is across from the 90. Or you straight. Yep. What's across from 60? Each problem is different. You either divide or multiply, depends on what you're looking for. Okay? So let's talk about law of sines. If I'm not mistaken, you guys did law of sines stuff last year. Yes, sir.
Can we go back to the left column? So it was 24 to 160 feet.
I don't remember. I'm not going to worry about vertical. I'm never going to ask you guys vertical height. It should be just half of it, so that's where it does come to that.
Learn it, know it in another class.
You will do angular velocity, angular speed next year, but you'll worry about how that stuff works itself through formulas and stuff later. We're not worrying about any of that now. So, you guys did law of sines. You guys did law of cosines last year, correct? Yes. I know you did. Yeah. Now, what happens here when we get into it, when we use law of sines, we use law of sines to solve triangles that are not right triangles. Okay? We use law of sines when you don't have a right triangle. You guys have all used this as the ratio stuff. You look at it in terms of the sine of an angle is to the side across from it, as the sine of another angle to this side across, and so on and so on. These formulas are, they always write it up with all three sides because you have all three parts of the triangles. Obviously, you're only going to be using 2 out of those 3 ratios every time. Okay. It is very user friendly when you do these. You're either solving for a side or you're solving for an angle. Depending upon how you set them up, it's a lot of cross multiplying and pressing some buttons and stuff like that in the calculator. What will happen is you're going to have 3 parts of a triangle. There are 6 total parts. you're going to have to find the other 3. Change it to start making some lists. Now, as we get into this, there will be some weirdness that does occur. There will be some stuff that I mentioned to you guys back in August that comes back into play today as well, if you remember what I said. So let's look at an example that's really fast. I know that excuse me, when we use law of sines, it's nothing more than the sine of an angle is to its side opposite, is the sine of some other angle to its side opposite, and sine of the other one is to its side. This is where we use capital letters for angles and lowercase letters for the sides opposite. I know you guys have all done that. This hasn't changed. Okay? For example, we're going to use this, and don't write this out real quick. We're going to use law of sines when we have 2 angles at a side, and this is going to be the angle-angle side case or angle-side angle. We can also use it when you have 2 sides and 1 angle, the side-side angle case, or angle side case if you'd like to be funny about it. Now, there is ass in math, and it does occur. There are some weirdness things that it happens of. And obviously we get the 3 sides, that's when we use law of cosines. And then if we have a side angle side with the included angle, we would also wind up using law of cosines. We'll talk about law of cosine stuff tomorrow. Okay. Now, when you use these things, obviously what I usually draw out, I'm going to draw pictures that look like this every single time. It's just really generic picture. I label it, and if I have an angle and a side opposite, I circle it to show that that's what I'm going to use both times to solve for the other parts. It's very, very user-friendly. For example, it says solve said triangle with angle C at 103, angle B at 28, and little b at 26. 2 things you're going to do right off the bat every single time. First, always draw a picture and label it. Second, write down the other parts you need to find. Okay? Pictures are never drawn to scale. It's just a triangle, ABC. Okay? Little a, little b, little c. I usually put my lowercase stuff on the interior. That way it doesn't get messy. Okay? From there, I label out my parts. Angle C is 103. Angle B is 28. And little b is 26. Which setup do you have the angle and the side opposite? With b's. So I usually just do this right off the bat. That means I'm going to use that as my ratio to solve the other 2 parts that I need to get. Okay? Now, what are the 3 things we have to solve for?
Little a, big A.
Yeah. Angle A, little c. So I'll make a list. Angle A, little c. By doing that, it reminds me, find 3 things, knucklehead. Write those 3 things down. All right? What's the easiest of those 3 things to find? Angle A. How do you find angle A? There's only 180 degrees in the triangle, so you just take the 2 that you have and you back it out. When you do that, what do you get?
49.
So I have 49 degrees right off the bat. Okay? So I have to find both side A and side C. So I set it up this way. Sine of our angle B, sine of 28, is to its side opposite, as the sine of angle A is to its side opposite. Sine of angle B, which was 28, that's what it was, to 26. C was 103, is to its side opposite, little c. I'm writing it down first before I go back into trying to solve it. At this point, it's just fraction equal fraction, guys. There's a lot of cross multiplying. Okay. Now, one of the things you should recognize is that I need to multiply by the 26 to move that, and then I do my change-o with the sign of 28, the A. Okay. Remember, you can exchange things on the diagonals because it's still the same. This one I just multiply to move up. So my A will equal 26 sine 49 over sine 28. I always write down what I'm going to put in the calculator before I do it. That way I know that I'm typing it correctly. Okay. If you'll notice, isn't side C in the same position as I wrote that out as side A? So should my math be the same to solve for it? That's kind of the trick. Little c will be 26 sine 103 over sine 8. Now you'll have to bear with me. My multi-view does not want to fire up. It does not want to close. It doesn't want to do anything. No, I'll just do it here. It works the same way. So 26 sine 49 fraction bar. So just do a little fraction bar, 26 sine 49 over sine of 28. Since I'm using the fraction bar here, it's okay that you have an open parenthesis at the end there. It's not going to change anything. Okay. You're going to be just fine. Hit enter, round to 2 digits, and I went up 41.8. What's that? Okay. Oh, sorry. So I got 41.8. Be okay with me on that?
Yes.
All right. If you got some weird number that meant you probably are in radian mode, make sure you're in degrees, guys. Make sure you're in degrees. Okay. 41.8. You don't want to do law of sines and radians and unit circles.
Oh, it's fine.
All right. Then I do the exact same thing with the other one. 5396. That sounds like what we got before. So what stinks about this, if these were side links and in a right triangle, we could always verify by using the Pythagorean theorem to see if you were close. With law of sines and eventually with law of cosines, it's really difficult to be able to do that because you really can't. So what I would just kind of bear in mind with is our first one was what, 41.8? So that was this one, 41.8. And then 96. Thank you. Really, the only thing that you can kind of do, it's kind of with a grain of salt that it makes sense-ish. Does the largest angle in the triangle have the longest side length across?
Yes. Yes.
Does the medium-ish have the median? So, you guys remember those rules? Remember when you did this? The bigger, go like everybody like this. Bigger the angle, what happens to this between your fingertips? That's why that works. You're an idiot. So you thought it? Sorry, I had a kid last hour and it said, wait, airplanes have wheels? It was not Tyler Beatty. And then he would ask, can I buy a candy bar? Does this vaguely ring a bell? Okay, good. Yep. Once again, let's walk through this one. Same idea. That first problem, if we go back to our, before I get too far into this one here, in this first example here, the stuff that we were given is we had angle, angle, side. Are we okay with that? We had 2 consecutive angles and 1 side across from them. So we had an angle, angle, side scenario.
Yeah.
Here, we draw this up. We have angle A, 18, little a at 16, and little c at 10. So again, just triangle. A, B, and C. So we have A at 18 degrees, little a is at 16, little c is at 10. What's that?
I was just saying, like, if you were to put A at the top.
It doesn't matter.
Exactly. As long as
It's not yet that, and that's what's nice about this. That's why we always have the big A's across from the little a. As long as you're consistent with that, you're gonna be fine. It's just habit for me to always go label it this manner. It's just how I've always done it. So if I started A at the top, I'd be like, what goes next? I'm not sure. So if you look at this one, you've got 2 angles in one side you have to find. So you write it down. And was it little b we need?
Yeah. Can you refresh my memory while you draw the angle? For the.
That means no, it's an angle, not a point. because you say point B, it didn't need to have a symbol in front of it. Angle, it denotes the fact that that's the vertex. Instead of saying angle ABC, because it has 3 letters, since it only has one consecutive, one possible vertex, we just use 1 letter.
Do we need the cross line?
Oh, is that what you're talking about?
Yeah.
Okay, that's how I grew up learning. This means the same thing. My handwriting is, as you know, awesome. That looks like a less than symbol. So, to me, I grew up with my geometry teacher, Mrs. Bender. She always put a little hook in her angle symbol, so I grew up always writing the little hook in there. It's no big deal. It's just preference, okay? What scenario is this? What are the letters they gave us for this case? Side angle. Oh! Or is it? Oh! Now, could you prove a triangle that with ASS? No, because there is no. You can say it. There's no ass in math. Okay. Now, anyway, in this case, though, what information do you have given to you? The A's, okay? What is it forcing you to find first? That. What?
I was gonna say question.
No, but what's it forcing you to find first?
What
other information? Let's start over here. Angle C. The only thing that you have otherwise in this problem is little c. So it's forcing you to find the angle of C. So we start with that. So we have the sine of A is to its side opposite. Okay? You guys with me so far?
Yeah.
Okay. Now, in this case, since you have to find an angle, that means eventually you'll have to use an inverse function. Okay? So the only thing we have to move to get the sine of C kind of by itself is to move the 10. You just multiply it. So you have 10 sine of 18 divided by 16 will equal the sine of C. So what I need to do is press all of that junk into the calculator. 10 sine 18.
Oh, wait, so reverse the sine of the second. So you do inverse sine.
Yep, make sure you're in your degree mode, okay? So 10 sine 18. If I hit enter, then I divide by 16, or use your fraction bar. Don't write it all as one string unless you close the parentheses. Something else will go wrong. That would be bad. This is my decimal value that equals the sine of C. From here, it's stored in the calculator. So all I have to do is hit second sine of my answer. This is why I was showing you guys how to use the answer button so many times, because this is where it becomes very prominent. Yep, 11 point something. 11.14 I got for angle C. You okay with that? Yes, sir.
Wait, I just like the other one is not like the
You'd have to arrow up and hit enter again, or write it all down. It only stores the previous one, or you'd have to store of that one, knowing you're going to have to use it again later on. There's a lot of other weirdness in doing it. Okay. Yeah, everything goes 2 decimals. Everything. Yeah, everything goes 2 decimals. Everything goes 2 decimals. So, excuse me. This one gives me 11.14 degrees. So now, what do I do to find angle B? Add them and subtract from 180. Good. So we do that. We take our 180, subtract out the 18, subtract out the 11.4. What'd you get? 150.86. And then I use that value, the sine of it, to its side to figure out little b. Okay? So we have the sine, go back to what you already used. Sine of 18 is the 16. Sine, move this over just a hair, of 150.86 over little b. Again, we've solved this one before. Multiply, divide. So let's see, 16 sine 150.86 divided by sine of 18. 2521. That's now, this problem, we started with what three values? We started with an angle and two sides, right? The way that the angles of the two sides were put up, though, showed it up to be the side-side angle, or ass, if you will. Don't roll your eyes at me. It's a funny joke. Huh?
How do you go from having two fractions equaling each other to being able to do?
I multiplied by 16. Bless you. 16 sine of 150 and change divided by sine of 18. Just cross multiplying. Okay. So, we started here, didn't we? This is where things get weird with this. Back in, and we had this written down in first hour, back on August 28th, I told you guys something that was kind of important that would show up again. What's that? Not covering the truth.
It is important though, and it will show up again. You told us you're
Probably, I don't know. So, don't write this down for right now, but what I want to show you is this. How many degrees are in a circle? Okay. So if I start here at 0, I go all the way around the circle counterclockwise, I end at, are we okay with that? Okay. What's it here? Okay, what's it up top? What's it downstairs?
2 seconds.
Is he wrong if it's negative 90? He just went the different direction. And we'll get there. We'll talk about negative angles later on, because those are our things. Now, let me ask you this. Let me see if you can do this. What quadrant would 40 degrees be in? First quadrant, okay?
Yeah.
So, if I draw in, I say this is 40 degrees here. That 40 degrees creates a triangle here. You have a horizontal distance, you have a vertical distance. Are we okay with that? Horizontal distance are what values in terms of x and y's? X's. Y's are vertical. Okay? So there's some ordered pair here, x and y. In the idea of ordered pairs, are x and y positive or negative in the first quadrant? Positive. Are they both positive?
Yes.
Okay. What happens when it goes to the second quadrant?
Why
Y is negative. Okay. Or sorry,
positive?
X is negative. X is positive. Sorry, I got mixed up there. What happens when you go to the third quadrant? And then over here. Positive, negative. Okay. So in essence, what you're saying is, if I take this point here and reflect it to here, I know that was weird. If I reflect it to here, those are horizontally across one another, correct? Would the y value stay the same? Yeah. Okay. The x value just becomes negative. Okay. So if I moved it vertically, the x's stay the same, and the y value just becomes negative. And then back to here, it's positive, negative, and this just goes back up top. Everybody with me so far? It's close enough. Okay? Yes, sir. It's whenever we do circle stuff, we always go counterclockwise. It was just the rules that that somebody did back in Greece. I wasn't there. Now, do you remember? Let me ask you before I get there. What comes first in the alphabet, sine or cosine? What comes first in the alphabet, x or y? Okay. Grab your calculator real quick. I'd like you to do the cosine and then the sine of 40. Cosine and sine of 40. What is the cosine of 40? 0.76. 0.77? Okay. What is the sine of 40? 0.64. I put those in terms of the x's and y coordinates because what came first in the alphabet, cosine or sine? Cosine. If you look at an angle, your cosine, isn't your cosine horizontal here? If my theta is placed right there? My sine is my vertical?
Yep.
Is my sine my y value? Cosine is my x value.
Yep.
Now, if I switch this to here, I'd have to maintain this angle to also be 40 degrees. If this value stays the same here, doesn't it? Now, if this is 40 degrees coming up from here now, because I'm measuring from the 180, how many degrees is it from 0 to here then? 140. Okay. What is the sine and the cosine of 140? What changed? So what you're saying is there's an acute and an obtuse angle that has the same value for sine. And this is why angle side side never works to prove triangles, because you never knew if you had acute or obtuse angles. Okay? So what happens then is if you go back to here, this first angle we found after we've had our 18 degrees, this first angle we found was 11.14. You okay with that? That's acute angle, isn't it? First quadrant. What's its angle in the second quadrant? What would you do to figure that out? Very good. Subtract it from 180. You find its supplement. You remember that?
Yeah.
So if I take 180 and I back out the 11.14, I get what? 168. Okay. So the sine of 168.86 and the sine of 11.14 is the same, because they're what we call a reference angle. How far an angle is off the x-axis. It's the same in both those two quadrants. Okay? That's why that works. Now, what happens with law of sines is something that you guys didn't learn about last year. Law of sines has this weird case. It's called ambiguous. It means basically when you have s, it's possible you could have two triangles, because you might have enough degrees to have both an acute and an obtuse angle to go along with the given angle. Okay? And we're not going to get to a ton of that today. I'm just kind of letting you guys see that there is a possibility that this does occur. Again, this is something you did not know about in geometry. It's just, just push the buttons. When you get to me, I'm going to have you guys check to see if it's possible. Now, the textbook has a really long-winded, and every textbook I've ever seen has this really long-winded, awful definition of how to check to see if this works. There's a really easy way. We always check the supplement. The supplementary angle of this, if you have to find an angle first, because you started with angle side side, you always check this supplementary angle, the 168.86. I add it to my given angle. Is that more or less than 180? It's more. This is like what, 186? That's too many degrees, which means can I have a second triangle? No. If it was less than 180, I could do a second triangle. And that's kind of what we're going to work towards. Okay? The textbook goes through this huge, long-winded, there's like 6 or 7 different cases you'd have to test. And you know what I'm talking about. Oh, stupid. Check this out. It's the easiest, quickest way to do it. Okay? So what happens here, let me skip ahead really fast before I get to the next example, is I'm not going to have you guys worry about pieces. Did I move it? I'm not going to have you guys worry about testing all of these different 6 cases for all this stuff to work through. All we're going to do when we get to this angle side side stuff, we're going to check the supplement. Add the supplement to the original angle. If there's more than 180 degrees, it's just one triangle. If it's less than 180, you've got 2 triangles, and I'll show you how to do it and set up again later on. Okay? It's just giving you guys the idea of how this is going to originally start. So let me go back here real quick. We know that it doesn't work for the second triangle, so all my old answers then would have just been filling in what we had. 150, 86, and then 25, 21. And again, all we have to do really is just to check to see if it actually worked itself through with the sides and the angles, if they match out. Yes, ma'am?
Like
I picked angle C to do next because I had side C across. So whatever, if I had side B across, I would have gone for angle B. It forces you to make it work because if you think about it, if I have sine of A and little a here, if I don't have either of these, I can't solve for both of them. So I'm looking for which one other one do I have. Okay. Let's try another one.
Oh, this is not.
Try another one. Okay. A lot of sines, a lot of cosines. This was fun. I like it. I like trig. I like trig a lot. This is one of my favorite things to do.
Chose to devote your life
It says a lot about me, right?
Yes.
Yep. So again, what's the first thing you're going to do? Draw it. Yeah, just draw a picture. A, B, and C. So angle A is 140, little a is 5, little c is 7. Why?
because it doesn't have to be. A shorter length. It would have to be longer.
Right. Okay. And then we go to the next problem. That's the idea. Can't you have two triangles, even if the one angle is 179 degrees, can I still make a triangle? Can you have, remember how the sides and the angles work? Remember, go like this. The bigger the angle, what about the sides going across your fingertips? They go further apart, right? So if you're at 140 degrees, that's a lot. That's fine, right? Can I have another angle in the triangle that has something further apart? That means that the other angle here has to be bigger than 140.
The same as.
No, this is going to be the biggest angle. Means it has to have a bigger side. Is 7 bigger than 5? All right. We do on time. Okay. Let's do one more. Then I'm gonna show you a little area trick. Okay. In this case here, notice that we're starting with an obtuse angle. If I'm starting with an obtuse angle, I'm already in the second quadrant, so do I have to worry about two triangles? No. I have to do that. Okay. So again, start. (105), 11, 5. What is this forcing you to find first? It's trying to get you to find angle A first. So you got to find angle A and angle C, and then little c. Use my silly trick of circling so you know which one you're going to use as your pivot, if you will. The sine value, the ratio for both missing pieces. So you have the sine of 105 is to 11. As the sine of A is to 5. So I have to find angle A first. In this case, I just multiply by the 5, put all that in my calculator, inverse it. So let's see, 5 sine 105 divided by 11. Inverse sine of my answer. I got 2604. All right. I know I don't have to check this one for a second triangle because my second angle on this is going to be obtuse. I already have an obtuse angle. I can't have more than one obtuse angle in a triangle, so it's going to be at most one that works. Now all I have to do is just add these two together, subtract it from 180 to get my angle C. What is that, 131.04? So 180 minus 131. $48.96. And and then I use that to find its side opposite. Okay? So sine 105 is 211. Is 2 little c. Multiply by 11, divide by the sine of 105. 11 sine 48 96 divided by the sine of 105, 8.59. Yo.
What did you get for
4896.
no for English?
2604.
Oh, so you can do that. Okay, so you can do sine and
If you wanted to, yeah, I would do that because it's too much. Too many things can go wrong. That's why I break into smaller chunks. Think of it this way: you're just multiplying by that reciprocal. Okay. Now, the other thing that law of sines allows us to be able to do is that you can use it to find areas of triangles that happen to be in a side angle side scenario. Okay. So if you have a triangle, that has a side, an angle, and a side. Okay. If you have a side angle side scenario, you can use this. 1/2 side times the side times the sine of the included angle. Yeah. The textbook writes it out 3 different ways just because there's 3 different steps depending on what angle you have. I always write it like this because it works for any time you have side angle side. If you have side angle side, you're always going to be able to do this in terms of getting an area. Okay? I just made up a quick little example of what side angle side looks like. Remember, that's just 2 sides and an included angle. Remember, the included angle means the angle in between. And that gives you your area. It's a nice little trick of how to do some of these. This scenario has shown up on ACTs, I know. I don't think it's shown up on an SAT, but I do remember seeing this problem. Like this, find the area of the triangle, and it was a side angle side setup. Okay. So the textbook writes it out like this, and I just wanted to kind of show you the easy version before you saw theirs. They write it out as 1/2 side sine of the angle, just like I was doing. Think about it. If you have the angle here and these 2 sides, you'd use this formula. If you have B and those 2 sides, you use this one. It's too long-winded. That's why I always just draw a picture. If I have my picture, A, B, and C. Angle A, 103. Maybe not. Excuse me, I knew it was good. Thank you, sorry. And then little c is at 17. See how I have side, angle, side? Just write it out. 1/2, side, side, sine of the angle. It gives you the area of the triangle. It is a really nice, easy way to do those. Okay. I'm not going to write out the 3 versions of it. There's another one for this when we do law of cosines. We'll get to tomorrow. I did not get enough information to you guys as far as what happens with the ambiguous case stuff. And tomorrow I'm going to be out all day doing the NHS selection stuff. So tomorrow I'm going to have a video for you guys of a couple of quick examples of the law of cosines, the 2 ways of setting those things up. Again, it's a lot of algebra, really a lot of buttons to press through. We'll probably hold off on doing the actual full-on ambiguous stuff until Thursday. But these should work out just fine for you for tonight. Excuse me. I'm pretty sure I backed out anything that was ambiguous So if you check answers and it tells you there's 2 triangles, I missed one, but pretty sure those should all work themselves through and go from there. Should be pretty quick. Remember, draw the diagrams as you fill them through. And I had that stuff on there. I don't put them live until we get to the dates. You asked me 4 times yesterday.
Who's sending it?
Oh yeah, you sent it to me 4 times.
Oh, it's also you?
Yes. Who do you think it sends it to?
I don't know.
To my website. Who would it send it to?
Wait, what are you trying to say? I thought it was like blocked on our test drive. Why is it
Just I don't turn them live. I don't turn them live, so we need all. You don't need to get too much information because you all messed up. There was a PDF. That was posted on PDF. What's up?